So very good evening, one and all gathered here. Today we are going to see about the concept of displacement work in a piston cylinder device, and next point function and path function. So both the concepts are from the same subject called the thermodynamics. So first let us see the concept of displacement work. Let us consider an engine cylinder and piston type arrangement as shown in the given figure. Let the gas present inside the cylinder is said to be a system from the given figure referring to the previous slide. Here, the gas is compressed inside the engine cylinder and the piston expands from the initial point to the final point with respect to the change in position due to the gas pressure. P1 and V1 are the initial pressure and volume of the cylinder. When the piston is subjected to at point position 1, so here this coordinate point we call as initial pressure and initial volume P1, V1. If the piston moves from point 1 to point 2, here final pressure and final volume that can be specified by P2 and V2. So piston is the only boundary that moves due to the variation in the gas pressure. This is the only boundary which separates both system and the surroundings. So due to the variation in the gas pressure, it moves from position 1 to position 2. From initial position 1, now the piston moves to the final position 2 in order to measure the final pressure and volume by expanding the gases inside the cylinder. And the following parameters, the list of notations are given in the next following slide. Let dl be the change in distance due to the displacement of the piston. So from the given picture, so the point, the space between 1 and 2, we call that as dl, the change in distance between the 2 points based on the movement of the piston from point 1 and 2. And A be the area occupied by the piston and F be the force acting on the piston. So this equation can be written as F is equal to P into A, where P is the pressure P acting on the piston and A is the area of the piston. So therefore the amount of work done by gas on the piston, so this can be given as dW, that represents a change in work done between the 2.1 and 2, between the two states. So from the initial diagram, so dW is equal to F into dl. So where dl, where dV is equal to displacement volume AdL. So F can be replaced by PA. So from the given equation, force acting on the piston is equal to P into A. So substitute this value in place of F, PA into dl. So now change in volume, displacement volume is equal to dV can be written as A dl, area with respect to the change in distance based on the displacement of piston. So now dW is equal to P dV. So dV is equal to AdL. So in the place of AdL, you substitute dV, change in displacement volume due to constant pressure. So now when the piston moves out from the initial position 1 to final position 2, by changing the volume from V1 to V2, that is V1 is the initial volume and V2 is the final volume inside the engine cylinder, the amount of work done by the system can be defined by the equation W is equal to integral PdV. So V1, V2 are the initial and final volume, lower limit and upper limit. So this is the final formula, the equation for displacement work. So before moving to the next concept, the point function and path function. So just we have saw about how the work done by the gas on the piston subjected to a given pressure by varying the volume between the two states. So that can be defined by the work done equation. So this is the thing which we have seen in the previous slide as a derivative. Now we are going to see the next concept in thermodynamics. What is the difference between point function and state function? So let us understand from this picture, from this graph. It is a PV diagram, pressure volume diagram. So first let us go with the point function. What is the meaning of point function? The point function is nothing but a thermodynamic variable. You take pressure and volume. Here there are two pressure values are given. P1, P2, V1, V2. Okay. So point function which define the initial state and the end state of the system that may vary according to the path. Say the value of P1 will be more than, will be less compared to the P2 final pressure. Similarly, V1 volume will be less compared to V2 final volume. So this value will be changed with respect to the point intercept, not depend on the path. So the point function is a thermodynamic property whose value will change according to the initial and final state, not depending on the path of the system. So P1, V1, P2, V2 are the coordinate point as defined in the graph. Now coming to the definition. So point function is said to be otherwise called as a state function, which has two transition state. Say initial state and final state. Initial state be 0.1 and final state be 0.2. So the property which depend only on these two states, say for example, pressure, volume, density. Okay. So the substance will begin to change only on the state of the system, not on the path. So then what is path function? See here, from point 1 to 2, path C, and from the same point 1 to 2, another alternate route or path we call as a path D. Okay, to reach from one state to another state, there are two different alternate paths. Suppose if I want to increase the volume from V1 to V2, either I can refer the path C or path D from the given graph. But anyhow, we have to reach to the same point from 1 to 2. But the path route may be alternate, it may be different. But we need to reach the end point from the starting point, okay, by following the alternate destination, either C or D. So now what is path function? It is also a thermodynamic property. So any change in the system that depends on the region of a path between the initial and final state. Say heat transfer, work transfer is one of the best example for path function. So the volume expands from V1 to V2. So it is a work done inside the cylinder of engine cylinder due to the gas pressure acting on the piston. So it is said to be a path function. So even though there are different paths are there, but from when you are reaching from one point to another point, the work done may be different. But however, you reach the same point in both the cases. How? Say refer the picture. So I want to travel the gas from point 1 to point 2 by expanding the piston from V1 to V2. So now I want to calculate the work done by the path D. So we need to select the area below the point 1, 2, V1, V2, then point 1, 2. This entire area to be shaded is taken into consideration. So this is considered to be the work done across the path D. Okay. The next figure, I want to find out the work done across the path C. So already we have calculated the work done up to path D. Now we need to take the total area under the graph. So up to path C, we need to shade the selected area such that we can compare the work done difference between the two diagrams. So in the initial diagram, the work done by the path D is less comparatively than the work done across the path C because it has more work. Okay, even though the work done may be different, but we have to start from the same point and the same destination, path 2, that is point number 2. So anyhow, we need to reach the same point number 2 in both the cases. Okay, if you go by path C or path D, anyhow, you have to reach the same point number 2 in either cases. So this is the in understanding the inference from the graph. So in today's lecture series, we saw about the basics of displacement work done by using engine cylinder piston type arrangement. Based on that, we derived the work done equation by showing that integral PdV subjected to initial volume V1 and V2. Next, we saw about path function and state function in thermodynamic property. The next meeting, we will see about the adiabatic process in thermodynamic relation and some more additional topics, the basic fundamentals of thermodynamics we will discuss in the next meeting. So thank you one and all for your kind continuous support. So thank you once again.